Okay, so I'm going to go ahead and I pulled up the template for transformations of the parent function. If you want to just pause the video and review this for a second, go ahead. Okay, I'm going to jump into the problem set here. Let's see, it says functions are stretched vertically when they are multiplied by a factor whose absolute value is what? Well, to stretch them, A is going to be the number that we multiply by. And so that's got to have an absolute value that is greater than greater than 1. Okay? And functions are shrunk vertically or compressed vertically when they are multiplied by a factor whose absolute value is less than 1. So what does this represent then? If we've got f of x equals the absolute value of x and we multiply that by 1/10, then that's going to be a vertical compression. Multiplying the absolute value function by a number whose absolute value is greater than 1 is a vertical stretch. So what if we start with the function f of x and we want to vertically compress by a factor of 1/10 and reflect over the x-axis? Well, I got to do two things then. I'm going to multiply the function by -1 and by 1/10. So we'll get negative 1/10. The negative is to reflect over the x-axis and the 1/10 is to vertically compress. We'll multiply f of x by both of those at the same time. This time I want to vertically stretch by a factor of 4 only. So g of x is just going to be 4 times f of x. I don't think I need that times sign though, do I? Okay. And to vertically stretch by a factor of 6 and reflect over the x-axis, that would just be -6 times f of x. Okay, now what about this? This time we want to horizontally stretch by a factor of 5. Okay, so that means that we're going to multiply x by the reciprocal of 5. Because it's a 1 over b, remember, in our template. So we're going to get f of, let's put that in parentheses, f of 1/5 x. To simultaneously compress by a factor of 1/3. So that means we're going to multiply by the reciprocal of that, multiply x by the reciprocal of that, which is 3, and reflect over the y-axis. Well, reflecting over the y-axis, remember, means that we're going to multiply x by -1. So multiplying x by 3 and by -1 at the same time means we'll multiply x by -3. To horizontally compress by a factor of 1/3, all we're going to do is just multiply x inside the function by the reciprocal of 1/3, which is 3. To vertically compress and reflect over the y-axis. Now let's look at that. So we've got two things going on. To vertically compress by a factor of 1/5, that's a value of a, so we're going to multiply the whole function by 1/5. Okay, but we're not done. We also need to reflect over the y-axis. Now if I were reflecting over the x-axis, I would make the 1/5 negative, because I would also have to multiply the function by -1. But I'm reflecting over the y-axis, which means that I have to multiply x by -1. This time we're going to horizontally stretch by a factor of 2 and reflect over the x-axis. So reflecting over the x-axis, remember, that means a is negative. So I'm going to multiply the whole function by -1. But to horizontally stretch, that means I'm going to multiply x by the reciprocal of 2, which is 1/2. So I've got minus f of inside the function, the reciprocal of 2, times x. There's my 1/b, remember. Last one. 2 is a doozy. To vertically compress by a factor of 1/9, translate left by 7 and down by 10. So what's that mean? I've got values then of a, h, and k to substitute into my template. So remember that my template here, I'll do it this way. I'll write it as a times f of x minus h plus k, and I'll just substitute values. So vertically compressed by 1/9, that means my a is going to be replaced by a 1/9. If I'm moving to the left, that's the negative x direction. So I'm moving to the left by 7. That means h is -7. So h minus -7 is the same as saying x plus 7. And then I'm going down by 10, which means k would have to be -10. Whoops, -10. There it is.